Boys, in the previous video, we have explained conditional probability. And I have given the definition of conditional probability and the symbols which are used to represent the conditional probability. We have discussed that PA/B is defined as probability of event A assuming that event B has actually occurred. So this thing we have discussed previously, PA/B. And this is called conditional probability of A under the assumption of B. Here, there are two events A and B. The event B will occur first. And after the occurrence of event B, event A will occur. The probability of A is affected by the occurrence of event B. And to evaluate PA/B, we have a formula, that is PA intersection B divided by PB. Remember it. Whatever remains after slash, that is B, that should be written here, PB. And the common probability of A and B should be written in the numerator, PA intersection B by PB. Or you can define PB/A as PB intersection A divided by PA. Here after slash we have event A, so this PA should be here, and the common of these two, PB intersection A, and you know PA intersection B and B intersection A both are same because common of A and B, common of B and A both are same. So this is our expansion of A/B. Now to evaluate PA/B, first of all we have to evaluate the probability of common portion and then probability of event B, whatever exists after this slash. Now suppose here PA/B, we define it is probability of event A. Now suppose A and B are independent. Suppose A and B are independent. Say independent. Then in that case, PA/B should be PA. Why? Because if the occurrence of A is unaffected by, if the probability of occurrence of A is unaffected by the occurrence of B, then in that case PA/B is nothing but PA. There is no impact of B if possible. Then in that case the expansion of PA/B is PA intersection B divided by PB. This is equal to PA. And when we cross multiply, we get PA intersection B is equal to PA into PB. So this is your result, for which we can say that the two events A and B are independent events. If A and B are independent events, then we have to prove that their common probability should be equals to PA into PB. So if you prove this result, you can prove easily that the two events are independent. Or vice versa. If this result happens, then we say that A and B are independent events. Now this result holds for any two arbitrary events A and B. If A and B are any two events, and for any two events, if PA intersection B is PA into PB, then we say that the two events are independent. Now let us try to prove few theorems based on this independent events. Now you see here, say we have a theorem. What theorem? If A and B are independent events, independent events prove that number one, A and B bar are also independent. Number two, A bar and B are also independent. Number three, A bar and B bar are also independent events. These three results may be treated as theorems here in probability and may be asked in your examination. Now, how to prove one by one? You see here, it is given that A and B are independent events. So, to start the theorem, we have to write, since A and B are independent events, therefore PA intersection B is equal to PA into PB. So this is the first result which we have, because A and B are independent. Now what we have to prove? In the first case, we have to prove that A and B bar are independent. Now in the previous video, we have discussed that A and B bar can be given by the axiom PA is equal to PA intersection B plus PA intersection B bar. This one is the axiom of probability. Axiom of probability. So from one of the axiom we have. So we can write, we know that. Here you can write, we know that PA is equal to PA intersection B plus PA intersection B bar. This result we have discussed in the previous video. Now, therefore, PA minus PA intersection B is equal to PA intersection B bar. Again, this PA intersection B should be written as PA into PB. So, PA minus PA into PB is equal to PA intersection B bar. And if you take PA common, you will get PA common, then in bracket you will get 1 minus PB. That is, this equals to PA intersection B bar. And this 1 minus PB is nothing but PB bar. So PA into PB bar is equal to PA intersection B bar. So what you observe here? That the probability of their common portion, intersection, is equal to the product of the probabilities of the two events. So that's why, therefore, A and B bar are also independent, events. So this is our proof of first part. Similarly, for the second part, you can take PB is equal to, for number 2, PB is equal to PA intersection B and plus PA bar intersection B. This one is also an axiom of probability. And we have discussed this axiom in the previous video. So from there you can learn that how this result happens. Now again, proceeding in the same fashion, you are able to prove that A bar and B are also independent events. This is left for you. Independent events. So you can prove it very easily. Now, for the third part, proof of third part, we have to prove that A bar and B bar are independent events. For third part. So for that, we have given PA intersection B is equal to PA into PB. And we have to prove PA bar intersection B bar is equal to, we have to prove that this should be equals to PA bar into PB bar. Then in that case, it will be A bar and B bar are independent events. So now how to prove? You see here, we can apply here De Morgan's theorem. Now using De Morgan's theorem, we can write this is equal to PA union B whole bar. And this De Morgan's theorem you have learned in class 11 set theory. See, in set theory you know that A union B whole bar is equal to A bar intersection B bar. And similarly A intersection B whole bar is equal to A bar union B bar. So these two results you know. And these two results are known as De Morgan's theorem. So using De Morgan's theorem, we can write this as PA union B whole bar, because PA union B whole bar, if we distribute this bar over the two events, this union becomes intersection, this result will appear. Now this one, if we take A union B as X, say then this becomes PX bar, and then PX bar is equal to 1 minus PX, that is A union B. PA bar, because we know that PA bar is equal to 1 minus PA. We know this result from elementary set theory. So PA bar is equal to 1 minus PA. So we have applied that result, 1 minus PA union B. Now extension of PA union B we know 1 minus, that is PA plus PB minus PA intersection B. This formula also we have discussed in the previous video. So from there you can learn it. Now again open this bracket. So what happens? 1 minus PA plus minus PB, and then plus this breaks out and it becomes PA into PB. It is because A and B are independent events. So we have to break it. Now what happens? That is 1 minus PA is PA bar, and minus PB you can take common. In the bracket you will get 1 minus PA. Now PA bar and then minus PB into PA bar. This one is PA bar. You can easily understood. So PA bar you can take common, and in the bracket you will get 1 minus PB, and further this 1 minus PB can be written as PB bar. So PA bar into PB bar. So what do you observe? PA bar intersection B bar, it becomes PA bar into PB bar. So this one says that A bar and B bar are also independent events. So these three results you must keep in mind. And I am giving you one more problem, and this is left for you for homework. You can prove if A bar and B bar are independent events, then prove that A and B are also independent events. You see here, this problem is left for you, that if A bar and B bar are independent events, then prove that A and B are also independent events. So try to do at your home. If not done, I will discuss this problem in the next video. Now you see here, we have to take few problems based on independent events. The question: for two independent events A and B, suppose P A intersection B bar is equal to 3 by 25, comma P A bar intersection B is equal to 8 by 25. PA comma PB greater than half. Find PA and PB. Say A and B are two independent events, and for these two independent events we have PA intersection B bar is equal to 3 by 25, PA bar intersection B is equal to 8 by 25. You have to find the value of PA and PB, but there is a restriction over PA and PB. You have to accept that value which is more than half. Now let us start the problem. Answer. You see, A and B are independent events. So A and B bar are also independent events. So we can write PA into PB bar is equal to 3 by 25 as per this result. Now this PB bar can be written as PA into 1 minus PB. You can write this is equal to 3 by 25. Let us take P as X and PB as Y. So it becomes 1 minus Y is equal to 3 by 25. So what is the value of X? X is equal to 3 by 25 into 1 minus Y. Let us take it as number 1. Again, from the second result, we can write PA bar into PB is equal to 8 by 25. So this PA bar can be written as 1 minus X into Y is equal to 8 by 25. We will try to take the help of comparison method to solve for values of X and Y. So for that, here we have taken the value of X. Here also we will try to find out the value of X. So 1 minus X is equal to 8 by 25Y. So 1 minus 8 by 25Y is equal to X. So you can take LCM. 25Y minus 8 by 25Y is equal to X. This is number 2. Now we will equate the two values of X. Now what happens? You see here. After equating the two values of X, we will have 3 by 25, 1 minus Y is equal to 25Y minus 8 divided by 25Y. So this 25 cancels out and we will try to cross multiply. 3Y is equal to, try to multiply 25Y minus 8, then minus 25Y square and then plus 8Y. Now take all the terms to one side. What happens? You see here. We have 25Y square, then minus 5Y, minus 5Y and then minus 25Y. So this is minus 30Y. And then plus 8 is equal to 0. Plus 8, I think. Yes. 25Y minus 25Y square minus 30Y plus 8 is equal to 0. Now we will try to factorize this one. We have the factor as 20, 10. So we can write 25Y square minus 20Y minus 10Y plus 8 is equal to 0. Now from here, these two, we can take 5 common, 5Y. So we have 5Y minus 4 and then minus 2 common, it is 5Y minus 4 is equal to 0. So the value of Y, what you will get from here is 2 by 5, comma 4 by 5. So the two values of Y you are getting, 2 by 5, 4 by 5. Therefore PB is equal to 2 by 5, comma 4 by 5. But which one is more than half? We have given PB should be greater than half. So this value, if you convert it in decimals, you will get 0.4 and this one you will get 0.8. So this should be admissible. We should reject this value since PB greater than half, therefore PB is equal to 4 by 5. Now once you know the value of PB, say, then try to find out the value of X taking Y is equal to 4 by 5. Therefore, X is equal to, from 1 you can write 3 divided by 25 into 1 minus 4 by 5. Now, if you take the LCM and invert it, what you will get? So, you are getting 3 by 5. Now, therefore, PA is equal to 3 by 5. You can observe that this PA is also more than half because this is 0.6. So these are the two values of PA and PB. So this is very, very important problem. Now boys, these are the cases of independent events. Now we have to discuss few problems based on conditional probability. Say, before starting conditional probability, we have to take a concept. That concept is the beginning form of Bayes theorem. We have to discuss this theorem, Bayes theorem. We will discuss it later on. But the beginning form of this Bayes theorem we have to discuss here. Say there are, for example, say there are 4 events in a sample space. Say A, B, C and D. And suppose there is one more event, say W, which occurs with all these 4 events. Now, if you are interested in finding the probability of W, How to get the probability of W? The probability of W you will get by taking probability of W intersection A plus probability of W intersection B plus probability of W intersection C plus probability of W intersection D. You see here, if you take the common portion of W and A, this portion will be added. WA. Then WB is this portion. Then WC is this portion. And then WD is this portion. Now, the common portions, all the common portions with these four events together with W, if you add, you will find the whole circle of W. So PW, you can write W intersection A plus W intersection B plus W intersection C plus W intersection D. This thing we have explained for 4 events. But if there may be 40 events, 400 events, 4 lakh events, for all the events, if there is an event which occurs with all these events, you have to find the probability of that particular event. Then in that case, you have to add the probabilities of intersection of that event with all other events which will happening there. Now, let us take a problem on it. Suppose we have, take a problem. Let us start from your book. Taking a problem from your book. Say, 2 sets of candidates are competing for the post of director in a company. The probability of their winning are respectively 0.6 and 0.4. If the first set wins, comma, the probability of introducing a new product is 0.8, whereas the probability of introducing new product with second set is 0.3. Find the probability of introducing the new product. Actually, the problems which are based on conditional probability are similar problem to this problem. You see here, whenever you are getting an if and then combination, if the first set wins, then, here it is then, the probability of introducing a new product means if then combination, it appears in your mind while translating the problem in your mind, then in that case you can easily understood that this problem is a problem of conditional probability. Now, how to solve this problem? First of all, try to read this problem carefully. 2 sets of candidates are competing for the post of directors in a company. Now, set 1, say here, set 2 here. The probability of winning first set is 0.6. Say first set is A and second set is B set. Now this first set A indicates that it has winning probability of 0.6. So PA, what we have is 0.6. And PB for second set, we have 0.4. You see, 0.6 for PA, 0.4 for PB. So these two sets are competing. Now, if the first set wins, means if A wins, the probability of introducing a new product, let W be the event of introducing new product. Say we have taken W as the event of introducing new product. Now W, the new product probability, if the first set wins, is 0.8. This means which event will occur first? At first, event A will occur, and after that W will occur. So we can write this using conditional probability PW/A. PW/A, probability of W such that A wins. Then in that case, we have this probability as 0.8. And in the same fashion, probability of introducing new product, if second set wins, that is PW/B is equal to 0.3. It is given that for the second set it is 0.3. So PW/B is equal to 0.3. And now you can easily solve the problem. What you have to find? Find the probability of introducing new product. Means you need PW. So how to get PW? This W event occurs with the two events, A and B. So we have to find their simultaneous probability with A and B, and we have to add the two probabilities together to get the probability of W. So expand it by conditional probability result. We can write PW intersection A by PA is equal to 0.8. So we can cross multiply. This implies PW intersection A is equal to 0.8 into PA. Now put down the value of PA. Now PA is given to you. What is the value of PA? PW intersection A is equal to 0.8 into 0.6. So it should be 0.48. So this is number one. And similarly, if you calculate PW intersection B from the second result, it will be 0.12. It appears to be 0.12. If you calculate it, PW intersection B by PB, now take PB to right hand side, value of PB you can write, so you will get 0.12. So therefore, PW is equal to what? PW is equal to PW intersection A plus PW intersection B. Now, here we have to add the two probabilities, 0.48 plus 0.12, and finally you are getting 0.60 as your answer. So this will be your answer. So in this way, actually most of the problems based on conditional probability are similar one, and in this way you can evaluate conditional probability of an event. So boys, we will discuss Bayes' theorem and few problems based on conditional probability in the next video, and that will complete our this topic probability. Thank you boys.